What if you want a base class that forces every child class to follow certain rules? Not optional behavior. Not you can override if you want, but mandatory structure. That's exactly what abstract classes in C# are designed for. In this video, you'll learn what abstract classes are, how abstract methods work, how they differ from virtual methods, when to use them in real applications. Let's start with the problem they solve. When building larger systems, you often want shared behavior in a base class, but also required behavior in every child class. For example, every shape must be able to calculate its area, but the way a circle calculates area is different from a rectangle. You don't want to guess whether a child class implemented that logic. You want to enforce it. That's where abstract classes come in. What an abstract class is. An abstract class is declared using the abstract keyword, cannot be instantiated directly, can contain normal methods, can contain abstract methods. The key rule: you cannot create an object from an abstract class. Why? Because it's meant to be a blueprint, not a finished object. Abstract methods explained. An abstract method has no body, has no implementation, must be overridden in child classes. It defines a contract. Every child class must implement this. If a child class doesn't implement it, the code won't compile. This gives you structural safety at compile time. Combining normal plus abstract methods. An abstract class can still contain fully implemented methods, fields, properties. This allows you to share common logic in the base class, force specific behavior in derived classes. It's a powerful combination. How abstract differs from virtual. This is critical. Virtual means a child class may override it. Abstract means a child class must override it. Abstract methods do not have implementations. Virtual methods do. This gives you precise design control. Real-world example: shapes. Imagine a base class called shape. Every shape must calculate its area, but you cannot define a universal area formula in the base class. So you declare an abstract method calculate area. Force every child class to implement it. Now, circle defines its own formula. Rectangle defines its own formula. But your architecture guarantees every shape can calculate area. That's strong design. What happens at runtime? You still benefit from polymorphism. You can store different shapes in a collection of type shape. When you call calculate area, C# runs the correct version for each object. Clean, predictable, professional level structure. Common beginner mistakes. Trying to create an object from an abstract class. Not allowed. Forgetting to implement abstract methods in child classes. Compiler error. Confusing abstract with interface. They serve similar but different purposes. We'll cover interfaces next. When to use abstract classes. Use abstract classes when there is a strong is-a relationship. You want shared logic. You want enforced structure. You want to provide partial implementation. Avoid them when classes are unrelated. You now understand what abstract classes are, what abstract methods are, how they differ from virtual methods, when to use them in real projects. If this helped, subscribe and comment what topic you want next. Next, we'll look at interfaces, which take architectural design even further.